Hi, this is the project of Hindi and Ram. It's basically a cascade ratio control with an external disturbance. That's the hydroelectric generator. We start from the control station. Looking at the monitor in here, we're looking at station 2 and station 1. Station 1 has the generator and the first tank, since they both are sharing the same flow, which splits. 60% goes to the generator and approximately 40%, which is varied every now and then, goes to the tank 1. And the other monitor could monitor the other station and the other tank, which is supposed to maintain the ratio and the set point of the first tank. Here's are the faceplates for the ratio, level, and flow. We can change the level of the first tank in there and monitor both the ratio and the flow. Coming down here, we have multiple instruments. Here's the Delta V control unit and a Schneider VFD to run the first pump. Down we have a 3 horsepower pump controlling the flow. The flow splits, as you can see, using a 1-inch pipe. Goes to the station, the generation station, and directs to the first tank. Here we're looking at a 6200 DV valve positioner and a control valve. This is the heart positioner. This is the heart protocol. Down we see the flow meter indicating the flow that goes to the tank based on the frequency or the run, the VFD. This is the frequency set forth. Now here at the second station, it's basically that we have the second tank that maintains the ratio. 30-51 Rosemount DB cell, which basically has a level indicator. On the first station we have a 1151 Rosemount level indicator there, both indicating the level of the tanks as the ratio are maintained. This station uses the same pump, a 3 horse pump with the same VFD, and it runs on a 60 Hertz constant. Even with that, we have on the other side another control valve with DV 6200 valve positioner. This is the final control, like controls the level of the tank regardless of the speed of the pump, which is set constant at 60 Hertz. Coming with its flow indicator as well. Here comes the part for the generator. The generator actually was built from scratch. It's a 9 coils star connected, and we're looking at 12 holes of 120 pound first magnets. The flywheel for the generator is called a Pelton wheel. It's basically designed to grasp the most of, like, possibly all the energy from the water. This Pelton wheel was 3D printed. The pockets and the flange mount and the flange socket, both are 3D printed. Internally, it might not be visible, but there's also a spacer between the two cutting discs, which were used to sandwich the pockets and make the wheel. Down here, we're looking at another piece that was 3D printed. The flanged socket, we have 5/16 inch shaft, and we needed a special made socket and a mount for it, which we had to 3D print. This is an 18 inches base. The supports are 10 inches high, 5 inches wide. As the generator spins, the pressure comes through an adjustable water hose nozzle. When the generator runs with no load, it goes up to 48 Hertz. which is basically, if you convert it to RPM, it's close to 3500 RPM. Once the load is put, frequency drops to 40, 42. Sometimes like the max we get is 42. And the voltage will drop based on the load. But without a load, the generator is up and running. Down here, we're looking at the control valve for the flow to the generator. It's another positioner, but this one is a traditional analog positioner, a Fisher type 1 and 1,2B, and it's an analog IB positioner. The outlet of the generator is controlled by a field bus positioner. This is the DV6000. It's a field bus and it's connected as a drain. Looking at the drain of the tank of the generator, we use two drains basically. One is the 1-inch pipe, which was initially the one we used to drain the tank, but since the inflow and the inflow was way higher than the outflow, water was accumulating, and hence we put another 1-inch pipe as a second drain to the same tank, and that's how we were able to overcome the building up of water issue. Now we're gonna run the station and see the operation of the complete set, maintaining the ratio while having the generator running. You can see the outcome there.